How can I solve a system of linear inequalities? So to do this, you first you graph both inequalities in the same graph. And when you graph an inequality, a linear inequality, you're always shading part of the graph. So in this case, when you graph two lines, there's going to be an overlapping section of shading, and that is your solution. So here's a simple example where I have y is greater than or equal to 3. That's the red line, and you can see this red line, approximately y is equal to 3, and everything above it is shaded red. Also on here is a green line for y is greater than or equal to 5/3 x plus 2. Notice I'm in slope-intercept form. I always like to convert my linear inequalities slope-intercept form so I can more easily graph them, and I put a point at positive 2 at the y-intercept, and then I went up 5, 1, 2, 3, 4, 5, and over 3, 1, 2, 3, and then I drew the line. And I shaded everything that was greater than or equal to it. And I found that there's this overlapping section, kind of like right here, you have this overlapping section. That is the solution. So this is the solution. So this is not, and this is not, but this overlapping section is the solution. Please note also a couple little things. The lines are solid because I have greater than or equal to in both cases. So the lines are solid, meaning that they're included within the set. And the solution set is this overlapping section. Now, sometimes you're going to be faced with inequalities that aren't as nice. For example, you might have an inequality 7x minus 4y is greater than negative 24. This is the trickiest one. You're going to have to type one you're going to have to deal with. So what I did is I subtracted to get it into slope-intercept form. I subtracted 7x from both sides. I ended up with negative 4y and then divided by negative 4. So I ended up having to flip my inequality symbol. I divided by a negative. Negative 24 divided by negative 4 and minus 7x divided by negative 4. When I simplify this out, I have y is less than 7/4 x plus 6. So here's my slope, here's my y-intercept. Of course, we're doing 2, we're a system. So the other inequality was 3x minus 8y is less than 40. So in that case, I took the 3x away from both sides. I had 40 minus 3x is greater than negative 8y. I had to divide by negative 8, which means I flip my inequality. Whenever you multiply or divide by a negative number, you flip the inequality symbol to make the statement remain true. So then I ended up with y is greater than negative 3/8 x minus 5. 40 divided by negative 8 got the 5. 3x divided by negative 8 is negative 3/8 x. So now I have this linear inequality. Both of these inequalities did not have the equal sign, so I had two dotted lines I had to graph. And once I graphed them using my slope at my y-intercepts and then the slopes, I used dotted lines to graph them. I then shaded the section, which in this case was greater than, and in this case was less than. And now you can see I have this overlapping section right here. So everything in this section that would in theory go on forever is the solution. And so now I have shown you how to solve a system of linear inequalities.